Hello everyone, this is Suresh from Azure ADB. Today our topic is how to determine whether your Unix time, epoch time values are in seconds or milliseconds. So we'll see how to find whether epoch values are in seconds or milliseconds. So we have different methods, approaches we can follow to find this. So first method is check the length or magnitude of the number. Suppose if it is seconds, then this range, that means that number range is 10 digit numbers. Suppose example is like this. So if you count this number, it should have 10 digits. Suppose if your number has 13 digit number, then you can tell as this in milliseconds. So timestamp in seconds and timestamp in milliseconds. And what is the rule of thumb is if the value is around 10 digits, it is in seconds. If your value is 13 digits, then we can consider it as milliseconds. So this is one approach. Next, we'll see how to check by using actual values. So what I'm doing here is I'm creating one sample data frame here. So first my data is with 13 digit number and second one I have with 10 digit number. So by using spark.create data frame, I'm creating first data frame and this I'm giving name as data in milliseconds because this is 13 digit. And I'm creating one more data frame that is a df underscore seconds. So this is I'm giving name as timestamp underscore seconds. So here I'm passing this 13 digit number and here I'm passing this 10 digit number. So now what I'm trying to do is I'm creating one column by using with column function and I'm giving name as milliseconds. And here I'm using the function from underscore Unix time. So normally what it does is from underscore Unix time, it will convert timestamp of in seconds or milliseconds, it will convert to timestamp format. So but this from underscore Unix time, by default, it supports 10 digit number. If you have suppose 13 digit number, so you have to divide by 1000. So then it will be converted to 10 digit number. Then this function will take that particular number. So here I'm not doing any dividing by 1000 to show the difference. So here what I'm doing is timestamp milliseconds. So that means I'm passing this value. So that means 13 digit number I'm passing here. So within from underscore Unix timestamp. So I want to see how it will convert. So similar way, I'm creating one more with column on this second data frame. So here also I'm using from underscore Unix time. So here I'm passing this value. So 10 digit number. So if you see now difference, so our first one is this one, df timestamp milliseconds. So here what I passed 13 digit number, this one. This 13 digit number I passed. So by using from underscore Unix time, if you try to convert this, see it giving like this. But if you see this one, this is the correct timestamp format? No, because C plus is there and this is not in correct year format. See total 2, 4, 5 digit are there. So that means 13 digit number See it not converting properly. So why? Because from underscore Unix time always expects timestamp value in seconds. But here we have milliseconds, so it not converting properly. But if you see in this particular case, so here we are passing this 10-digit number. And if you see here, this is 10-digit number. And if you see here, this is correctly converting in timestamp format. And if you see overall, so this is our actual value. This is 13-digit number. After using Unix underscore timestamp, it converting like this. See, this is telling that clearly invalid timestamp value. So similarly, this is 10-digit number and this is correctly converting in timestamp format. See, this is correctly converting timestamp format. By looking itself, we can tell that. So which is correct timestamp value, which is wrong. So this is second method. And next method is divide by 1000 and try again. If you see here, this for both data frames, I directly used those values 13 digit and 10 digit. So here I'm not used divide by 1000. So here what I'm trying to do is, so I'm using same code here and for first value, that means whatever you are passing this value, this 13 digit value, so I'm dividing by 1000. So if I divide by 1000, what will happen? These three zeros will go and this will become 10-digit number. So then it will correctly convert into timestamp format. So next seconds. So here I'm passing 10-digit number. So that is our second data frame is 10-digit number and it correctly converting. Now if you see here, these two are both now. So this is a third method and this is the correct method as compared to previous one. So next final one is, suppose if your data frame has a combination of both 13-digit number and 10-digit number, then how to handle that one for converting to timestamp by using from underscore Unix time. So here what I'm doing is, first I created data frame by using this data. So after creating data frame, so this is my initial data. And if you see here, some values are 13-digit number and some values are 10-digit number. So on top of this, what I'm trying to do is, so I'm trying to filter the values by using when condition, when and otherwise condition. So in when condition, what I given is, so first I'm getting the length of the value. Suppose, so here I given Unix time underscore ms, this particular column. So it will check record by record. So first it will check this record. So length of this record. So see here, this length of this record, if it is greater than or equal to 13, then what it has to do is this call of time mx. That means our first record should divide with 1000 and it should convert to long data type. So otherwise it directly convert to long value. And if you see here, see our first record is 13-digit number. So as per this logic and it dividing by 1000. So then it converted to 10-digit number. And if you come to second record, so this is 10-digit, length is 10, but our condition is greater than or equal to 13. So this is not satisfying, then directly it will come to otherwise condition. In otherwise condition, what is there? This record, simply it converting to long data type. It not doing any changes in this. So similar way here, 13-digit number. So it matching to this particular logic. So it dividing by 1000. So we are getting 10-digit number. So similar way, it will go like this. Since this 10-digit number as it is will get this 13-digit number, it will divide by 1000, you will get 10-digit. Here 10-digit is there, you will get 10-digit. So here 13-digit is there. If you divide by 1000, you will get 10-digit number. So here it is by using when and otherwise condition. First it filtered, means it got all 10-digit numbers here. So on top of this, what I'm doing is I'm using with column and I given column name as this, and I'm applying from underscore Unix time on this particular column, TS underscore seconds. So now what it does is it will convert all these 10-digit records into proper timestamp format. Okay, so finally, what is the summary is? So first you check the value has 13 digits. If it is 13 digits, then it is milliseconds. If your value is 10 digits, then it is in seconds. So for cross verifying, use from underscore Unix time. So if date looks wrong, then likely wrong unit. Okay, so this we explained about first method. So try dividing by 1000. So that means if you divide by 1000, it will convert milliseconds to seconds. Okay, so overall, if you see this one, if it is 10 digits, it is in seconds. So if it is 13 digits, it is in milliseconds. So that's how you can differentiate your Unix time value is in seconds or milliseconds. So that's all about this video. If you really like this video, please like and subscribe. Thank you.